All right, so this is the third week of our remote lessons, and this one is going to be very short and sweet. And when you finish this guy, you're going to be halfway done. Now, it is going to be short and sweet, but some of the problems will get a little bit more challenging. We did trim this down a bit, but we felt these were kind of the things you needed to see that would maybe help you actually in life a little bit. So the first part was just an introduction of surface area and volume. Should have been basic review, and we didn't do quite as much tricky stuff as we probably would have in class. This one is going to be the same kind of story. We're not going to do it quite as tricky, but it is going to be a little harder than those basic ones. Now, this first idea, you should have seen converting units in the past. I'm not sure what grade level it would have been, but I like to think of converting units by using the multiplication of one rule. If we multiply things by one, they don't change. And then we're going to look at cross-canceling with fractions is kind of applied in this. Not necessarily mathematically sound way, but in a nice way so that you know how to set up your conversion factor and you're never confused about whether you're multiplying or dividing. So it's more of a logistical kind of trick than it is necessarily a mathematical method. Whoops, I went ahead when I shouldn't have. So let me go back to this slide. Now, the examples we're going to do together are really simple, basic conversions that are within the standard system. What you're going to be dealing with in the assignment is going to be more conversion between standard and metric. And so you need to be aware of these conversion facts. They should be posted in the form for you to use. And so you're going to want to look at these factors. So we're going to look at this first one. It's, again, really pretty painless. This is the easy part of this day's assignment. So what we're looking at first is we're trying to figure out how many yards are in 14 feet. So what I want to do is I just want to set up 14 feet, and you can definitely abbreviate that unit as a fraction. And so we can make anything a fraction by dividing it by 1. So this is having a lot to do with that identity property of 1. When we divide by 1, the value doesn't change. When we multiply by 1, it doesn't change. Now, what's going to be neat about our version of 1 in this case is the units are really going to matter. So if I know these two values are equal, if I did 1 yard divided by 3 feet, that is going to be equal to 1. And so because this is happening, I'm allowed to multiply it by this value, and I won't be changing the value of the 14 feet. What's going to end up happening is I'm going to be changing the unit. Now, I could use this one, or I could use this one. And so this is where you want to use that cross-canceling thing that you know to kind of help you to be able to figure out which ratio should I use. Because this conversion fact here, 3 feet equals 1 yard, can be written as a ratio with the yard on top and the feet on bottom, or the feet on top and the yard on bottom. So it's really kind of your choice. What we want to choose is we want to cancel this feet. We want to change the feet into yards. So that means if I want to get rid of the feet, I need the feet on the bottom from the conversion fact. So the 3 feet are going to go in the bottom, and the 1 yard is going to go on the top. And so you should have one thing in this setup that is the unit. And when it's on the top, then it's going to multiply that value by 1. So the multiply isn't going to matter. But with this 3 feet on the bottom, what's going to happen is you're going to end up having to divide 14 by 3. So the other thing, again, thinking that cross-canceling, the whole reason we want the feet in the bottom is this foot measure is going to cancel this foot measure. And again, that's really not mathematically sound, but that's how I remember how to do it. I want the feet to cancel. I want to be left with the yards. So now knowing I want to be left with the yards, 14 doesn't divide evenly by 3. So I'm just going to multiply it straight across, and it's going to be 14 thirds yards. Now, I really don't plan to accept that. You're going to have to give me a decimal value. So you can use your calculator to do that. I can actually do this one by hand. I can show you how to do that real fast if you ever have to do it by hand. So there's a rule, and let me show you it up here as well, that can help you with putting division in the right order. The least desirable positions stick together. So the last in line, the bottom of the stack, and left outside of the house all go in those positions. So whatever number is last in line, bottom of the stack goes outside of the house. So this is how I would set it up to work it out with long division. 3 goes into 14 4 times, which would give me 12. Subtract that out, I get 2. Now you have a couple of options. You can say it's at this point, you can write your remainder as an undone division or a fraction. So you would say 4 and 2/3, or you can keep dividing it out, and I promise you're going to get 4.6666666. So you would say 4.67 if I told you to round it to a certain place, like the hundredth. You could say 4.7 if it was rounded to the tenth. And our directions should be pretty clear in the form. If you do have any concerns or questions, be sure to let us know. So this is how you would set it up and work it. So now let's look at the next one. So this one is wanting us to figure out how many feet or inches, excuse me, are in 3.5 feet. So I'm going to start out with my known measurement, which is the 3.5 feet. I'm going to make it a fraction by putting a 1 underneath it, and then I want to multiply it by a value of 1 that's created from this conversion factor. Again, what I want to happen is I want the feet to cancel and I want to go to inches. So this 1 foot is what's going to go in the denominator or the bottom to be divided, and then the 12 inches is going to go in the top. So you can see this time that what's going to actually happen is we're going to multiply 3.5 by 12. The feet are going to cancel out. These ones are irrelevant now. And so what I end up with is 3.5 times 12. So I'm just going to do 3.5 times 12 in my calculator because I'm feeling a little lazy right now. And we end up with 42 inches. Again, in the forms, I forgot to mention this, we only want the number. We do not want the label because that's going to cause us some issues with being able to key it in and grade it correctly online. So again, the numbers are all that matters. So that's converting units. It's a really simple task. We're not going to apply the converting units into the effects of scaling. When you convert the units before you do a calculation or even after, it is going to have an impact on things when we're talking about 2 and 3 dimensional figures. So that's something you could look into further, but the main idea is we just wanted you to be able to convert some things. All right, next task is looking at effects of scaling similar solids. If the solid is going to be similar, that means that the scale factor has to be applied to every single linear measurement. If they are similar, the corresponding ratios of their linear measures will be equal. So we've talked about in the past how scale factor works. Scale factor is always copy over original. And so we could prove this is similar. I'm going to say this is the original or the pre-image, and this is the copy or the image. So if I say that copy on this edge here is 4 and original is 2, if I divide that out, I get 2. Okay, on this one, copy is 8. Original is 4. I divide that out, I get 2. On this edge, on the far side over here, copy is 6. Original is 3. If I do 6 divided by 3, I also get 2. So by doing this, I can prove that the solids are similar. So then the next thing we want to think about, well, how is that going to change when we're looking at area? So if we look at area, the length of this or the base of this rectangular shape at the base of this prism is 4 in the original, and now it's 8. So what happened was the base got multiplied by 2. And then notice the height also got multiplied by 2. So the area would be 2 times 2 bigger, so it would be 4 times the original size, and we could prove that with just a small bit of math. 4 times 3 would be 12, and 8 times 6 would be 48. So how does this change with area? Area is going to end up being your scale squared. And it's kind of easy to remember because area is in square units. How is this going to be different with volume? Well, it's going to be kind of the same thing. So if you look at it, not only was the base and the height of the rectangular base going to be multiplied by 2, but the actual overall height of the prism is going to double as well. So this one's going to end up being 8 times bigger. And we can finish that off if we take the 12 from the previous problem and multiply it by the height of 2 for that original prism, we get 24. And then if we take the 48 from the copy and we multiply it by 4, we're going to get 182. Is that right? I better check that. I don't know if I can do that in my head today. Oh, 192. See, I did mess up. All right, so 192. So then now I'm going to come over here and I'm going to look at that. Well, what would 192 divided by 24 give me? And so if I do 192, excuse me, divided by 24, Lo and behold, I get 8. So the copy is 8 times the original volume. So again, very similar to the idea with area. What's going to happen if you noticed here? That scale wasn't just applied once, it was applied twice, 3 times. So with volume, you're always going to have scale cubed. And knowing this little trick will save you some time with some of the problems. Let me rewrite that. That looks terrible. So it's cubed, scale cubed. So be aware that's what's going to happen when those two instances occur. The last thing that we have to look at, so this is the last direction for today, and the last thing you're going to have to deal with in the assignment is there will be some effects of scaling things that are non-similar solids. If they're not similar, it's going to happen when one of the dimensions isn't changed, or basically not all of the dimensions are going to be changed with that same scale factor. To find the effects of this type of scaling, you're going to have to actually physically calculate the values like we did in the previous example to show that our theory was right with the pattern we were seeing. But you're going to have to do that for this one every time because the pattern's going to change a little bit. So how many times larger would the volume of the pyramid be if we double the edge length of the square base? So what I'm going to have to do first is I'm going to have to find the volume originally. So we're going to find the volume originally. So the volume of this pyramid is going to be not 1/2, 1/3. Miss King's getting a little loopy. So it's going to be 1/3 area of the base times the height. So this would be 1/3 times the base area would be 8 squared, which is 64 because it's a square base. And then the height is 3. Well, half of 64 would be 32. 32 times 3 would be 96. So my original volume is 96. So now I want to think, okay, well, what's going to happen if what are we doing? Doubling the length of the square base. So what we're going to end up with now is our volume would be 1/3 times the area of the base is going to be 16 squared this time, times our height is still going to remain 3. So I'm going to actually do this in my calculator. So 16 squared times 3, and then we're going to divide by 3, and we get 256. So this area is or volume, my God, 256. So then now to figure out, well, how many times larger is this copy that we made by just changing those base lengths? We would do 256 divided by 96, and we'd see how many times larger is it. And I'm getting a decimal value. It is 2/3. So it's 2 2/3 larger, or 2.67 times larger. So that would be how you would work a problem like that. If we're looking at the surface area, so if you forgot the surface area formula, the surface area of this particular pyramid is going to be 1/2 the perimeter of the base times the slant height plus the area of the base. So the problem with this is we don't know slant height. So we would again have to use Pythagorean theorem. So do expect to have some Pythagorean theorem problems in here. I made this one super easy on myself. So if the whole way across the square is 8, halfway would be 4. So we know the general height. So the triangle we're looking at, and this should look very familiar. Hopefully some of you know this as well. It's a 4 by 3, and we don't know the c. So if we don't know the c squared, the way we calculate that is the square root of 4 squared plus 3 squared. And I already can tell you that's going to give me 5 because this is a lovely what we call Pythagorean triple. And so really simple. So now my surface area would end up being, well, 8 times 4, because I have 4 lengths of 8 to make the perimeter, would be 32. So it's going to be 1/2 times 32 times that slant height or lateral height. It actually has another name, slant height. I forgot to mention that in the other videos. The lateral height of 5 plus the base area, which would be 64. So half of 32 would be 16. 16 times 5 is going to be 80. We're going to double check that. Yeah, so 80 plus 64. I'm going to do that in the calculator too. It's getting kind of close to lunchtime. I'm getting a little silly. So we get a surface area of 144 for the original. So this is the original. So again, this is original. This is the copy. Okay, this one is original. And now we're going to do the copy. So the surface area of the copy, what's going to change is our perimeter. So all of these are going to double. So what we're going to have is 16 times 4. So our perimeter of our base, maybe, lost my pen, sorry, would be 16 times 4 times our lateral height we've already discussed was 5. And then the area of the base is gonna, oh, actually that's gonna change too. I take it back. It's gonna be 16 squared, which I should know at this point. I'm kind of depressed about that. 256. And so now we've just got to do the math for this. So 16 times 4 times 5 divided by 2. So that gives me, this is 160 plus the 256. So that surface area is going to end up being 416. And again, this is the copy. So then now finally, to get the final answer for how many times larger is the surface area, let me go back up and box this one too. So if anyone's looking at it on hard copy, it may not be as confusing. We would do 416 divided by 144. So 416 divided by 144, and we end up with 2.888888. So that's 2 8/9 if I'm not out of my mind. So 2, and we're going to say approximate again. We're going to say 2.89. So we should be telling you to round these. I hope I didn't set up the form bad. If I did, let me know. We'll fix it. But this would be what you would say would be the how many times larger did the surface area get? Whoops. My daughter just kicked me. So we're going to keep that. I hope that helped. Good luck.